What's up, everybody? So, for this video, I'm going to be talking about, just the introduction to graphing functions. This is, section 5.1 to 5.5 in the textbook, I'm pretty sure, and I'm doing it on my notes app today, just because last time was a complete disaster trying to do it with the Google Slides. That's a little less organized, but, what works, I guess. So, first things first, the first, function I'm going to talk about is a linear function, and the, equation for this that you're most often going to see is y equals ax plus b. Sometimes you'll see people write mx instead of ax, even now. I'll still say m equals, whatever. So what each part of this equation is, you probably already know this. A is just going to be your slope, and then b is going to be your y-intercept. You'll see what I mean. All right. Can I scroll down? No? No? I guess not. So let me sketch a little graph for you. So here's my x-axis, here's my y-axis. This is just gonna be the first quadrant, okay? This is obvious. Linear functions are of course linear. They're just a straight line. They can be positive, like this right here. They can be negative, like this right here. Yeah. So I don't know what I'm saying. One sec. I don't want to overcomplicate this because this is just a linear function. You all probably know this. This is something you learn y equals mx plus b in the 6th or 7th grade. So here, when a is greater than 0, this function, the y equals ax, is going to be increasing. So when your slope is positive, when you have a positive slope, you're going to have a positive graph. And then of course, when a is less than 0, it will be decreasing. You'll end up with a negative slope. I just don't want to talk into that too much, or else it's just going to get confusing. And please let me scroll down. There we go. I'm not going to be doing much proofs in this video. I'll also make another video if anyone else needs anything else, because the textbook kind of gets really wordy with the proofs and a bunch of other stuff, but I'm not too worried about it. Next function I'm going to be talking about is a quadratic function. That's an N. It looks like an R function. So quadratic function, the equation you're going to see for this is mostly y equals ax squared plus bx plus c. And the graph, I'll just draw it for you, here, is going to look a bit something like this. This shape is called a parabola. You most likely already know that. Quadratic functions have, here's the properties of, the y equals x squared, whatnot, of the function y equals x squared. Here's the properties of it as listed in the textbook. First off, your minimum is at x equals 0.
I said minimum at x equals 0, but it's y equals 0. You only have minimums and maximums with the range. Yeah.
At x equals 0. As you can see by this, so y equals x squared has no translations whatsoever, so it's just, boop, x equals 0. The graph, the second property is, the graph is symmetric. So if I take a line, if I take 2 points and draw a parallel line, in between points, they're going to be equidistant apart. So, this is, say, D, and say this is D, and say, that is, R. I'm just making up letters right now. I'm actually going to go into another video, because it does go into more depth about it in the textbook. I'll make another video on that. I just don't want to bore everyone else with quadratic functions right now. Your third property of the function y equals x squared is that on the positive side, this side, it's going to be increasing, and then on the negative side, it's going to be decreasing. So if we pretend we have a little, let's just purple. Pretend we have you see how this is going down? This is what we call, it's going to be negative. The slope is negative. And then the slope for this one is positive, Yeah. That's all I have to say about quadratic functions for now. I said I'll make another video later because quadratic functions are really interesting. Polynomials. Cannot spell. Polynomials. So, hello. The textbook separates polynomials from quadratic functions. Technically, a quadratic function, I guess, is a polynomial. A polynomial is just an expression contains indeterminates, which is just a variable, it is a variable, and coefficients. So quadratic functions, I'm pretty sure, are polynomials. I don't know why the textbook separated these. It just gave a few examples of what a polynomial graph would look like. So here, I'll draw one. So this is going to be a cubic graph, so it'd be y equals x cubed to the power of 3. And the textbook did not, I don't really have anything crazy to say about it. And then in the blue, what did I just draw? You know what, never mind. We'll worry about that later. Hello. We'll worry about that later. Don't have too much to say about polynomials on their own. I'm going to move on to exponential functions. So this is really most often going to be shown by y equals a to the power of x. And the graph here is going to look something like this. That was bad. That's bad. Let me undo. It's even worse, but whatever. So when a is greater than 1, your function's going to be increasing. And then when a is in between 1 and 0, your function's actually going to be decreasing. So that's going to be like exponential growth and exponential decay. The function's only defined if a is, sorry, my sister's yelling, if a is greater than 0. So a has to be greater than 0, a can't be 0, a can't be negative 15, you know, whatever. Next, I'll talk about one of my favorite parent functions, the logarithmic function. It's gorgeous handwriting, which is mostly, you're going to see it written as y equals log base a of x. Well, that's how it's written in the textbook. Honestly, I like using log base b because, you know, base starts with b, but who cares? So logarithmic functions and exponential functions are going to be inverses of each other. So you can, you know, if c equals log base a of b, it's this, you know, you can also write that exponentially as a to the power of c equals b. So if you don't know what a logarithmic function is, you're going to learn soon. Basically, like, if 2 to the power of 2 is 4, then log base 2 of 4 is just 2, if that makes any sense. And they're going to be modeled kind of, I'll actually draw two graphs. Ooh, I'm not an artist, if you cannot tell. So, like this. And then it could actually also be like this. I'll actually write this out. This would be y equals log base, let's say 2 of x. And this would be like y equals log base, like 1/2 of x. I'll put x in parentheses to make it easier to understand. And so, properties of logarithmic functions. The first one, the base can't be 1. So you can't have log base 1, okay? Because, you know, if a is 1, then log base a of x is just not a function. That's what the textbook says, and that actually makes sense. So, you know, that can't be done, and I'll show you why. So if you have log base 1 of whatever, I'll show you how it looks exponential form. So your base, your base is 1, you know, 1 to the power of 2 is just going to be 1. 1 to the power of 3 is just 1. 1 to the power of 5,000 is just 1. And you know with functions, you can only have like one output per every input. So if you were to graph this, it would just be whatever. It doesn't work, you know, because your input's just 1. It's not going to pass the vertical line test if you ever learned about that. Your next, sorry, my sister is making noises. Oh, my pencil turned off, that's why I can't. There we go. Next, property of logarithmic functions, if, you know, a has to be greater than 0, so the domain is going to consist of positive real numbers, you know, it's not going to go into the negatives, no. The third property is there's not going to be a y-intercept, as you can see, like in the little graph I drew up here. Let me put little arrows to make it make more sense. This y-axis right here, there is a horizontal asymptote here. This is never going to cross the y-axis. There's not going to be an intercept there, you know, stuff like that. So, no y-intercept. This is all from the textbook, by the way. I'm just pulling all this from the textbook. The fourth property of logarithmic functions is, you know, your function here is going to be increasing when a is greater than 1, so it increases. And then, same thing, when a is sandwiched in between, 1 and 0, it decreases. It's the same thing, it can't be 0, I'm also going to be talking about the natural log. That is horrible handwriting, I'm sorry. Natural log. So your most used base is going to be e, Don't worry about it too much right now, but natural log is just denoted by ln of x. And yeah, just whatever. And I already mentioned earlier that exponential and logarithmic functions are inverses of each other, and that makes them symmetric to each other. So here, let me do a really, really bad drawing of the two that I drew earlier. Okay. And yeah, this is really bad. But that's really bad. It's meant to be like this side should mirror this side. I just can't draw it, but whatever. And that's kind of all that the textbook mentioned. Like, I'm not including any of the proofs. I'm trying to keep this simple. But I'm also just going to mention something that wasn't mentioned in the textbook, and that is rational functions. A rational function is basically you have a polynomial in the numerator and a polynomial in the denominator. And, of course, the denominator can't equal to 0. You just can't divide by 0. And their graphs look all sorts of different ways. You'll see it mostly like that, or, it could be opposite. It could be like that. Or it could be all like that with some horizontal asymptotes. I'm not an artist, I'm sorry. But since polynomial functions weren't even mentioned in this chapter of the textbook, I'm not going to worry about it too much. As I said, I'm going to make another video talking about more about quadratic functions and the proofs on that, because that was interesting, but I know a lot of people, they don't need that. They don't even need this, and I'm tired. So yeah, that's all.